So the second section for the trig is evaluating the functions. There are some trig functions you really should just know because they're used over and over again. And they're the ones that are based off of these two triangles. The 30, 60, 90 triangle and the 45, 45, 90 triangle. So I have a 30, 60, 90 sketched out for you, and we want to know the sine of 30 degrees. So here's my 30-degree angle, and we know sine is opposite over hypotenuse. So that's 1/2. Cosine 30 is adjacent over hypotenuse. So that's the square root of 3 over 2. And tangent of 30 is opposite over adjacent. So 1 over the square root of 3. And if you rationalize that, it's the square root of 3 over 3. Now the 60 degrees is built off the same triangle, so they're going to have the same values. They're just going to be in different positions. Sine of 60 is square root of 3 over 2, which is the same as the cosine of 30. Cosine of 60 is adjacent over hypotenuse, so 1/2, which again is the same as sine of 30. And then tangent of 60 is square root of 3 over 1. For the 45, 45, 90, these legs are exactly the same. So sine of 45, it doesn't matter which one you pick. Sine is going to be opposite over hypotenuse, so 1 over square root of 2. And again, if you rationalize it, you get square root of 2 over 2. Cosine is going to give you the exact same thing. And then the tangent of 45 is 1 over 1, so we just get 1 for that. On the next page, I have the chart of those ones that we just talked about, the 30, 60, 90, the 45, 45, 90, and then I have 0 in there. And this, again, it's in your best interest to try and memorize these because you'll be using them a lot in a lot of different math courses. And also in any engineering type courses you might take. So for all other angles, we use the ratios of the sides or we use our calculators, depending on the problem. So calculator exercises, here we have sine, cosine, and tangent. So sine of 27, first of all, I want to make sure it's in degrees because that's what we're going to be working in. And this DEG there tells me it's the degrees. If not, I'd have to change it here. That's degrees, that's for radians, and that's for gradients. But we want to be in degrees. So I'm going to hit just sine of 27. And that's 0.4539905. I'm just going to put it to the nearest thousandth. 0.454. And then tangent of 53. 1.327. And cosine of 125 is negative 0.574. So if we already know the angle, all we have to do is hit the trig function and plug in that angle. If we don't know the angle, then we have to go and to the inverse. So this sine to -1 doesn't mean reciprocal. It means the inverse of sine. Same with cosine and tangent. So if tangent is 1.35, we want to find the angle. So I have it written out there for you, but I just wanted to show you. So I'm going to hit second function, tangent, and you see that -1. So that means I'm trying to find the inverse. And then 1.35. And I get an angle of 53.47. So trying to find the angle, if we don't know it, you have to use the inverse. If you do know it, you just use the trig function. So I have cosine z is 0.47. I'm going to hit second function, cosine, and 0.47. And that angle is 61.9657. So I'm just going to round it off to 61.97. Inverse sine of 0.15 is 8.627. And the inverse tangent of 0.99 is 44.712. So let's look at solving these triangles. The side opposite angle W has length, so here's angle W, the opposite has length 10. Adjacent has length 24, right? The adjacent is what helps form it, but never the hypotenuse. Side opposite angle B has length 24. Side adjacent to angle B is 10, and the hypotenuse is 26. So the sine of W, it's opposite over hypotenuse, so it's 10 over 26, and then you can reduce that. The cosine is 24 over 26. And the tangent of W, opposite over adjacent, so that's 10 over 24. Sine of B, 24 over 26. Cosine of B, 10 over 26. Tangent of B, 24 over 10. And again, all those can be reduced. And then they want to know what angle B is and what angle W is. So angle B, I'm going to hit second function sine 24 over 26. And 67.38. For angle W, I could do the inverse again, or I can just use the fact that all triangles add up to 180. So if I do 180 minus the 90 for that right angle, minus the 67.38 for the angle we just found, that's going to give me what angle W is. And it's 22.62. Now if you didn't want to do that, we could just do the inverse trig. So I could do second function tangent 10 over 24, and I get 22.6198. So there's my 22.62. Here we want to find the length and round to the nearest hundredth. And they want the length of AF. So this is the side that we're looking for. So that's going to determine which trig function I use. I'm given that angle 42. I have the adjacent side, and I want to know the hypotenuse. So cosine 42 equals 6 over x. And multiply by x, divide by that cosine, we get x is equal to 6 divided by cosine 42. And that I can plug in my calculator. And rounding to the nearest hundredth, it's 8.07. Here we want to find SO. So we have adjacent and opposite. So that's going to be tangent. Tangent 34 equals opposite over adjacent. So 10 divided by tangent 34 gives me 14.83. And then this last one, find the length of KU. So I have an angle, again the opposite, and then I have hypotenuse, so that's sine. So sine 73 equals x over 17. Multiply both sides by the 17. And we get 16.26.